before we get to the rectangular coordinate system, I'm going to put a program in your calculator I think you might need. Whether you need it now or not is up to you. But so I'm going to insert this right back here. Okay. What I want to do is the quadratic formula. I talked about this with a gentleman last night who was actually going through the quadratic formula. I said, why you waste your breath? Give him the program and move on. He goes, I'm not giving him the program until November. I go, it's October. Close enough. Give it to him. So he's not going to give it to him until November. I'll give it to you now. Why? Because I expect you to be able to use this to answer the questions I'm going to ask. You get no points for knowing the quadratic formula. And if you ever forget this program, everybody knows the manual calculations. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's what x equals, correct? So far, so good. Now, if you don't like programming a calculator, that's fine. But once I show programming, a lot of people really get into it. And they start writing other programs. That's good, except for tests. I'll walk around, check your calculator. Something I don't like, I'll delete the whole thing. All programs will be gone that you put in there. So keep that in mind that there's some ethics involved in writing programs. So what I want to do is I want to write a program to solve a quadratic equation. I'm going to call it the quadratic program. QAD with a P on it, okay? That's the name of the program. All right? So let's go through and do that. What's the first thing you do with a quadratic program? You're always taught, you never did it, but you're always taught to check the discriminant. This is a discriminant, b squared minus 4ac, right? That's a discriminant. Okay? So I have to put a number in for A, a number in for B, and a number in for C. I'm going to do that right now. So go to your calculator. If you don't keep up, well, sorry. Go to Program, which is in the middle of the calculator next to Apps. Go to New. And you'll see the alpha show up. That means whatever key you press, the letter value will show up. Program the new, or if you already have it, you can leave it. That's fine, so you're all right. Okay. So I'm going to go to, where's the Q at? Q, U, A, D, P. Okay. My A is up above math. Yeah, you got to hit alpha. Okay. So, quadratic program. Okay? It might have to take some searching, but you'll find it. So, once you're done with naming the program, you press enter. And now, every step has to be separated by a colon. Okay? I told you I'd take a lot of computer science classes when we did this. So I'm going to go to Program again, hit PRGM. Then I'm going to go to I/O, which stands for Input Output. Okay? I hit Program, I hit I/O. Now I'm going to go to Prompt. That means when I hit my program, the following letters will come up. Go to alpha A, comma, alpha C, or alpha B, comma, alpha C. I put prompt. Okay? Comma is in mine's next to the x squared above the 7, next to the catty corner from the log button.
Do you have to have alpha before all this?
I did. Okay? The whole idea is I'm going to do this one time for the rest of the year. I'll never have to remember the quadratic program the rest of the year. Okay? That's the whole idea. So alpha A, comma, alpha B, comma, alpha C. All right? Now, that means when I hit the program, the first thing will pop up is says, what does A equal? Okay? Then it'll say, then you type in a number. What does B equal? And you type in another number. So, also, whenever you make a program, you always should have a hard copy of it somewhere, so you should be writing these down. In case you drop your calculator on the way to a trig test, you might have a way of putting it back in before you get here. Why don't you ask me to do it? I'll be busy. I won't have time to do it. So, Program, prompt, there we go. And now I'm going to do some calculations. I'm going to take alpha b squared minus 4 times alpha a times alpha c. Some calculators you do not have to separate the 4 and the a and the c with multiplication. Some you do. That is the discriminant. I put alpha b squared minus 4 alpha a times alpha c. I have not hit enter after the b squared minus 4ac yet because I want to add one more thing. I don't hit enter yet. I just want b squared minus 4 alpha a. Oh, up here? You always hit enter to get a new colon to show up. You always hit enter to get a new colon to show up. So, I want that as my discriminant. Okay? No, doesn't matter. We'll try these out in a minute. Debugging is a lot of fun. Store this STO in the bottom left-hand corner. I'm going to take that calculation and put it into what's called the discriminant. What would be a great letter for a discriminant? D, alpha D. I hit store, which is in the bottom left. Then I hit alpha D. So that calculation in the red circle is now stored in this letter D. Okay? All right, fantastic. I'm going to press enter because I need a new line. I need a new thought. Now I think I'm ready. I'm going to take the opposite of B, alpha B. And in the quadratic program, you do plus or minus, right? I can't tell the calculator plus or minus, so I'm going to tell it to do plus first, plus the square root of D. And make sure you close that parentheses off underneath the square root. I know, I can't see the letters, D. And then I'm going to close off the square root. I'm going to close off the numerator with another parentheses, and I have to divide it by what? 2a. You guys are always so, well, okay, I used to coach the math team here. We would show up against a school, and some kids would be carrying 3 or 4 calculators. Our kids would make fun of them and didn't understand why they were winning. I simply said they have 3 or 4 calculators because they have them all programmed. When one is running, give them the answers, they type in another problem so it runs, and they type in another problem so it runs. They don't use a paper and a pencil except for writing down the answer. Oh. This is one small program that you can use, okay? So if you had more programs like filled up, you need another calculator. So the point is, if you get the hang of this, I want you to try to program. I think it's neat. Store. Oh, no, not store. Sorry. Press enter. I'm done with that calculation. Now I'm going to go back to program, I/O, and I want to display. You can either scroll down or hit the number 3 on my calculator. I want to display my answer. My answer key is above the negative, so I'm going to hit second and answer. It gives me the answer of that calculation. Okay? You can get all fancy and dress it up a little bit, but I'm not going to. Mine's above the negative, ANS. And now I have to do it again, right? Parentheses, the opposite of B, oops, clear. The opposite of B minus the square root of D. And I'm going to close off my numerator, divided by 2a. And then what do I want to do with that? I want to display it again, don't I? So I'm going to go to Program, I/O, Display, Second Answer. Okay? Display is under Program, slide it over to I/O, Display. I/O stands for Input and Output. If you're ever on a screen you don't like it, just press Clear, and you go back to where your program was, your last screen. Yep? One's the plus and one's the minus. Okay? I can't do a simultaneous calculation on the calculator. When you're done with this, this isn't like a computer. You don't have to press Save. Everything is saved as is. So the only thing I want to do now is quit. Okay? Now I want to solve the equation just to test it. What's the answer to x squared minus 9 equals 0? I always have 2. I just press clear or quit. When I was all typed in, I probably pressed quit. Went back to the home screen. So what's the answer to x squared minus 9? X equals plus or minus 3. What's the answer to x squared plus 9? Plus or minus 3i. Okay? So I'm going to go back to my calculator. I've never done the quadratic program in complex mode. I'll try it once just for fun. Mode. I know. So you'll get an error message. Okay? Program, execute the quadratic program. Press enter. And it says, are you sure you want to run this? You press enter again. Yep. You have to go to memory management. So, okay. Okay. For A, I put 1. For B, I put 0. And for C, I put negative 9. And I got 3 and negative 3 as the answers. Fantastic. Oh, because in the quadratic, the number in front of the x squared is 1. There is no number in front of the x, so I put 0. And C is the number by itself. Now I'm going to try the other one. The 1, the 0, and the 9. I'll press enter. I got it worked! 3i, negative 3i. Sweet! Okay. Yeah, because the 82s don't have complex mode. Well, you typed something in wrong then. Mine works. How many other people's work? Nice job. All right. And any debugging we can work on, but I'm just happy that's in your calculators now. Okay? All right. You forgot the square root. Mm-hmm. There we go. All right. Now I got to get through some homework. The rectangular, that was my one fun thing. I got another one planned later on in the year. Rectangular coordinate systems. Rectangular coordinate systems is a way of graphing out in a very inefficient manner because to get somewhere, you always have to go horizontally first and vertically second. You can let anything you want be the horizontal and vertical components. The most common, of course, is x and y. So anyway, we're going to talk about the rectangular coordinate system and go through and review some things you remember from algebra. Okay? All right. Don't forget, give me when it's 5 because we're on a different schedule today. So let's get started. The quadrants. I don't know if you remember, but 1 is in the first quadrant. 2, it goes counterclockwise, then 3, and then 4. We talked about the unit circle already. So we know that this is when the x is negative and the y is positive. We know in the third quadrant they're both negative. We know in the fourth quadrant you have a positive and you have a negative relationship between the two. Okay? That's not too difficult. You go over A, you got B, you're home free. All right? What did you say? Oh. So anyway, you can go over and you can go up, and that's how you do the rectangular coordinate system. Not very difficult at all. All right? Any questions on the quadrants? Because you're going to be using this in a different way, different than you're used to, actually. So, on here it says plot the points A, B, C, D, and E on the coordinate plane. Whenever you do this, you just make a sketch. Make a sketch, you go back 3, and you go up 1, and you list it as A. This book has a lot to do. Don't try to put these on your graphing calculator. It won't work. You won't see what you want to see. If you get a little bit more advanced with it, you can, but in this case, If I don't use a calculator, it's probably because it's not worth it. B is 3 and 1. C is -2, -3. I need to go down a little bit. -2, -3. Oh, sorry, that's just a C. It's a C. D is 0, 3. There's D. And E is 2, -3. 2, -3 is E. Yeah, it looks like a pentagon. It says join the segments AB, then BC, CD.
Star.
It is DE and EA. Okay? So that's what happens when you join them. I'm going to talk more about the actual window itself. A window is a viewing screen in which you look at a drawing. In this window, you're going to see me reference a few things. It's a good thing you wrote this down in your notes, because you ask me a question, I'll say reference your notes. If I go backwards, this is -5, 0, correct? If I go over here, this is 5, 0, correct? And if I go up all the way to the top, that is 1, 2, 3, 4, also 0, 5, and down at the bottom is 0, -5. Whenever this book, or whenever a homework problem gives you an example of a graph, you assume that the scale is 1 unless it otherwise tells you, okay? You assume it's 1. Why am I bringing that up? Because in this book, if you want to see a picture, they'll say the x minimum is -5, the x maximum is 5, and the x scale is 1. Okay? Do you see how those numbers came to be? -5, 5, and 1. And they'll say the y, or the y scale, or the y minimum is -5, the y maximum is 5, and the y scale is 1. And this is actually how they'll give you the information. Somewhere in the problem, or somewhere by the sketch, you'll see this bracket. And they'll say -5 to 5, 1 bracket, or times -5 to 5 to 1, and close it off. This means these are the x dimensions, these are the y dimensions. You need to know that because those are underneath your window command at the top of the calculator. Go to your calculator. Anything graphing is the top 5 buttons. Anything graphing related is the top. You go to your window and you punch in -5, 5, 1, and there's your scale. And then you can do the same thing for the y minimum, -5, 5, and 1. Do not change X resolution. Mine's set at 1. I'll leave it at 1. You can change it when you get to more advanced graphing, but leave it alone. My also advice is when you play games on these calculators, the games change the window and the settings. It's up to you to make sure they're in the correct settings if I ask you to do something in a certain window. My favorite window for algebra is if I go to, and I want to set it up automatically, or if you want to see the window, press graph. There you go. There's the 5 by 5, or sorry, -5 to 5, -5 to 5 screen, okay? Now, my favorite window I always go back to for algebra is Zoom 6. It's the standard window. Why? Because almost all algebraic calculations are done between -10 to 10 on the x and the y scale of 1. That's the first window I always go to. You can go to Zoom and you can scroll down to standard if you like, or you can just press Zoom 6. There's all kinds of other stuff. That's the main window I use. I use Zoom 6 a lot, and I go from there. Sure, there's times you have to change the window. That's your responsibility, and there'll be a homework section later on you changing the window. So that's how you can get a graph to look like that. You can actually draw the star on there, but it's not worth the time or the effort, okay? But that's how the window will be related to you in the calculations. -5 to 5 to 1 by -5 to 5 to 1. You have to know that means x minimum, x maximum, x scale, y min, y max, y scale. Nice. We're moving on. Questions about it? Everybody find the window?
Yeah.
Yep. Just go to Zoom and 6.
Can you just quit?
Yeah, you can quit when you're done.
Windows in it for some reason already, and every time I try to hit like.
That's because you need to be in function mode. There you go, and normal. Go to Zoom, and now 6. There you go. Yep. Because in your calculator, everything should be, in my calculator, everything's over here except for the complex. So everything should be on the far left. You don't change it unless I say we change our calculators today. That's under mode. That's how the calculator displays the answer and calculates things. Okay?
Well, then whenever I hit like this, now when I hit window, it's like, instead of -5, it's -10.
Right. That's the Zoom standard window. Okay? That's what it automatically goes to. Okay? All right. Let's see what else we got planned. Find the coordinates of A through F. Well, this ought to be pretty easy. A is known as what? What's the name we give to A? Okay. The coordinates are 1, 2, 3, 4, 0, 4. A is also known as what? The y-intercept. It's where a dot or a graph crosses the y-axis. Okay? E. Of course, I'm not going in order. I'm going from the top down. The coordinates for E are 2, 2. Very good. And you know that because they did not change the scale. You assume it to be a 1-to-1 relationship. Okay? B is known as what? X-intercept. So it's -4, 0. Notice the x-intercept has 0 for the y-coordinates. X-intercept. D is 4, 0. And finally F, -2, -2. And C, 1, 2, 3, 4, 0, -4. Another y-intercept, okay? Should be all review. Everything should be fine. And when you're doing this, you can make one picture for like 6 or 8 questions, wherever you need to. All right? So, but anyway, it should be really easy tomorrow. I got another surprise planned. I told you there was 2, right? Well, I think they're going to do another one. Nah, I'm not. Not today.
You said 2.
I said 2. We'll do another one tomorrow. Remind me. Here is the distance formula and the midpoint formula. You could, except that it's not allowed right now. If you don't play around with it, it's fine, but you have to exit it out for the test. I'm on the fence right now whether to allow the distance program or not. So anyway, jot those down if you need it. And if you don't, then we'll get started with some examples right away. But I don't really use the distance formula. I use the Pythagorean theorem. You know, it's the same thing, in my opinion. You have 2 points. The subscript P1 is x1, y1. And then I have P2, which is x2, y2. This leg is known as x2 minus x1. This leg is y2 minus y1. That's how you find the legs. Pythagorean theorem is you square the legs, and this gives you the distance of the hypotenuse. Okay? But I know a lot of people like to memorize formulas. That's fine. And there's one to memorize, the distance formula. The midpoint formula. The triangle? That's how you find the length of a leg. To find this length, you take this one and subtract this one, and it gives you how far it is. Like if, well, we'll do an example, and you'll see what I mean. The midpoint formula, obviously you add and divide by 2. It's the point halfway between. Now, don't think these are rum-dum formulas because of your past. Remember, you're going to get a college application of these formulas, not the simple x and y equations. Okay? So, yes, you have to know the formulas, but more importantly, you have to know how to apply them to a situation. All right. I'm excited. You ready to get started? Everybody have the formulas written down that wants them? Good. All right. So find the distance between A and B. This is example number 10. Negative 2, negative 5. 1, 2. There's A. Negative 2, negative 5. And then B is 4, 6. 2, 3. Now, sometimes I do use the distance formula. 2, 3, 4, 5, 6. But in this case, I probably won't. 4, 6. See, I'm a little different in that when I see this problem, I instantly think it's a right triangle. So how far is it from A to B on this leg? How far is it from negative 2 to 4? It's 6 away, right? And if I go straight up, the rectangular coordinate system, you always move in a rectangular fashion. If I go straight up, how far is it from negative 5 to 6? 11. So the hypotenuse is the leg squared plus the other leg squared, and I take the square root. And you leave your answer in terms of an exact value. How'd I get 6? Oh, well, negative 2, I have to take 2 steps to get to the origin, right? Then I take 4 more steps to get to 4. Yeah. So I just went from negative 2 to 4. And there's negative 1, 0, 1, 2, 3, 4. There's 6 steps. Yeah, I always find the lengths of the legs. Okay. But if you want to like crank out and do that long, you know, that's fine. But 36 and 121, square root of 157. Let's see, is that prime? 12, 13, not divisible by 4 or 3 or 4 or 2 or 5 or 7? No, darn it. 11? Definitely not. Anyway, you get the idea. The midpoint. That's this point right here in the middle. So you add them together. What's 4 plus negative 2? Divided by 2 is 1. And then you do the same thing. 6 plus negative 5 is 1. Divided by 2 is a half. Oh, my sketch is off by a little bit. That's okay. It's a sketch. So the midpoint, you take negative 2 plus 4 divided by 2. And then you took negative 5 plus 6 divided by 2. 2 divided by 2 is 1, and that's a half. The picture is optional, but I like to draw pictures. Okay? So that's the midpoint. Nice and neat. Questions on the distance formula or the midpoint? All right. Now, don't forget, sometimes I do traditionally use the distance formula. Let's try this one. You guys try this one on your own. The distance from negative, and I won't draw a picture this time because I know it's confusing to some people. Actually, I don't care. I'm going to draw a picture. 1, 2, you're here to learn anyway. Yep. I would say this is x2, and this is y2, and this is x1, and this is y1. 1, 1/2. What'd you get? I think it's 1, 1/2. Let me check. Negative 5 and 6 is 1. I think you forgot to divide by 2. Okay? Negative 4, 7. And 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There's B. 0, negative 8. All righty. How far is this segment? Oh. I love all these colors. Let me see what I got. From here to here is 15. From here to here is 4. So I got the square root of 4 squared plus 15 squared, 16 plus 225. Anybody else at the square root of 241? Nice. No, you don't. One of the cool kids do, like me. Oh, you are too. On your calculator, you could take Second quit. Clear. View. You can take, what was the point, negative 4.7? I would do this, negative 4 minus 0 squared plus 7 minus a negative 8 squared. And then I would go from there, 241. That's the square root of 241. And then I would see if I could break that down. Okay? I know it's not divisible by 3 or 9, so I'd probably leave it for right now, unless I had more time to play with it. Okay. Show that the triangle with vertices A, B, and C is a right triangle and find its area. How do you show something's a right triangle? Yeah, I left it at square root of 241. 1, 2, 3, 4, 5, 6. 1, 2, 3. This is negative 6, 3. 1, 2, 3, 4, 5. This is 0, 5. And this is 1, 2, 3. 1, 2, 3, 4, 5. C. Oh, yeah. Looks like it's off 1, doesn't it? How do you tell something's a right triangle? Yeah? Yeah, see if the Pythagorean theorem works. Is that a right angle? Well, what's the distance from A to C? Let's see, that is the square root of 5 squared plus, from negative 6 to negative 1 is 5, right? Then from 3 to 5 is 2, plus 2 squared. So 25 plus 4 is, that leg is the square root of 29. What's the distance from C to B? Well, the square root of 4 squared. 3, or from negative 1 to 3 is 4. Negative 5 to 5 is 10. So 100 plus 16 is the square root of 116. Ooh. And this one, negative 6 to 3 is 9, so that's 81. 9 squared, right? And from 3 to negative 5 is 8 squared is 64. So that's the square root of 145. Do you think that AC squared plus BC squared equals AB squared? I don't know. Square root of 29 squared plus the square root of 116 squared. Does that equal the square root of 145 squared? Yes, it does. So therefore, yes, it is a right triangle. You just find the distances, see if it solves Pythagorean theorem. You got to learn to do things a little quicker. You'll get the hang of it. 20. I like this question. How many more do I have? Somewhere around in here. 5 minutes? All right, let's get this one done. A is 5 to negative 8. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 5 to negative 8. Right? B is negative 6, 2. 1, 2, 3, 4, 5, 6. 1, 2. B, negative 6, 2. How do you find the point on this segment that's 3/4 of the way from A to B? Andrew? Midpoint, check. Okay, so 5, negative 6 would be negative 1/2. My picture's off a little bit. Then 2 to negative 8 is negative 6. Negative 6 plus 5 is negative 1, right? Yeah, I am. Negative 6. We are. We have to do two things to get 3/4. A half and a half. It makes a fourth, right? So that is negative 6, negative 3. Boy, my picture's way off. And which am I going to do half again? Am I going to go halfway to A or halfway to B? Yeah, I think it says 3/4 of the way from A to B. Right, I have to do the midpoint again with that one. So I have to take negative 6 plus a negative a half and divide by 2. And I have to take 2 plus a negative 3 and divide by 2. Huh? Yeah. And then this whole distance right here is the midpoint, or 3/4 of the way. Nice. Well, that's negative 6.5. Negative 13. Negative 13/4. I did the midpoint, and I did the midpoint of my half. Right. And that's negative a half. Nice. I like that question. So I'll try to get through 23. On what page? Page, I don't know, 100 and some? 200? 300? 400 once? Well, it's section 2.1. 101. Thank you, section 2.1. All right, got the rest of the time to get started. But the quadratic program was worth it.